chapter 4, number 8, our NAV, our net asset value is offering price times 1 minus the front load. We get NAV equals $12.30 times 1 minus 0.05 to 5%. Our NAV is 11.69. Then moving further down, problem number 9, it's the NAV of the fund. And that formula is the total value fund minus manager fee divided by outstanding shares. Our NAV of the fund is 42 million minus 30,000 divided by 4 million. So then we do the math. Our NAV of the fund is $10.49. Should I leave it up there or erase it?
What's the difference between the front end and back end load?
The front end load is where the fee of the front end load.
Which one's better? Did you guys look at the book in the book where it showed the net after load fees for performance for front end and back end load funds? Which one's provided the highest net fee return?
Oh yeah, we talked about that.
Well, not necessarily. Actually, they showed the back end showed a better net fee performance. So it's really just preference. Do I want to pay the fee up front or do I want to pay it on the back end?
Did you say you always pay front?
I pay up front because I want to get it done and I don't want to be paying fees up the back end. It's just a preference. I don't mind taking a little hit. It's just I don't want to pay the fee on the back end. Yeah, because some other guys are going to put some stuff. Okay, go ahead. Oh, let's get the picture.
Yeah.
Okay.
Everyone good?
So who's going next?
I'll
Who's,
go.
okay. And as you know, somebody re-races, somebody else puts the next one up.
Okay, so this problem is chapter 5, CFA problem, number 1. All these numbers are given, you're just expecting, or you're calculating the expected return of stock X and stock Y. So all these numbers are given 0.2 times 20% plus 0.5 times 18% plus 0.3 times 50%. And your expected return for stock X is 20%. And then you do the same thing for stock Y, which is 0.2 times 15% plus 0.5 times 20 plus 0.3 times 10%. And your expected return for stock Y is 10%.
This is chapter 6, number 21. The earnings, expected earnings on the portfolio would be 11%. The variation of the portfolio is 15, and the risk-free rate is 5. And we want to know how much of the assets we can put in this risky portfolio in order to achieve this expected rate of return of 8%. So you're going to get your 8% here. You're going to have the risk-free rate plus Y, I guess times, or yeah, plus Y times 11%, which is the expected return on the portfolio, minus the 5%, which is the risk-free rate. We get 0.8 minus 0.05, and then 0.11 minus 0.05, and then overall we get like 50% you should put in that portfolio. And then B asks what the standard deviation of it would be, and then you get the variance equals Y times the variance of the portfolio. So we go 0.5% here, which is from over here, it's like given this 15%, I'm sorry. And then the 5% is the risk-free rate, so you get those two and you times them together and you get 7.5%, which would be the standard deviation of it. And the number C asks which client would be more risky if they wanted a certain standard deviation. The second client wanted like 15% standard deviation on that portfolio, so the first client is more risk averse because the standard deviation is lower.
Nice job.
Thanks.
So the next one I'm going to be doing is CFA problem 4. It's going off the same numbers that Matt did. We have to find the standard deviations of stock X and stock Y, or the variances and standard deviations. So based off the numbers here, you go 0.2 times the quantity of negative 0.20 minus 0.20 squared, 0.5 times the quantity of 0.18 minus 0.20 squared, plus 0.3 times the quantity of 0.5 minus 0.2 squared. And these values here, which will give you 5.92% as the variance. You then take the square root of that to get a standard deviation of 24.33% for stock X. You repeat the process for stock Y, which will come out to give you 1.75% variance. Take the standard deviation of that, or take the square root of that, and give you 13.23% as the standard deviation for stock Y.
Thank you.
We need a picture of that?
Who's got 6?
Which one? That?
Chapter 615.
Yeah. No, go ahead, Desmond.
I got chapter 6, numbers 13 and 14. Given information was the percentage given to the investment portfolio as well as the T-bill. So 30% for the T-bill, and then 70% for the investment portfolio. And then the T-bill rate was 8%, and the return on investment was, or the effective rate of return on investment was 18%. So we multiply the T-bill rate times what percentage of the portfolio is T-bills, and then do the same for the investment. Add those together, and you get the effective rate of return, which is 15%. And then they ask for the standard deviation for that, and you do the, what was that, the amount of the investment, the percentage of that, times the effective rate of return. No, sorry, the expected, yeah, it was portfolio rate, and that's what gives you the 19.6% here. And then they ask for the portfolio, the investment, what was the word for it?
The allocation.
No, the percentage for,
The percentage for the risky portfolio?
no, it was just the percentage of the portfolio with each one of these.
Oh, it's the probability?
Yeah. And then that's just 4.7, that's the amount of the whole portfolio that's being done for the investments. And then this is how much was for stock A, B, and C. So this just gives you the amount of stock that was for stock A, B, and C for the entire portfolio.
Got it. So that's the allocation. Thank you. You can erase it after you're done. Matt, do you have another one?
I'll put it out of
Okay.
All right, so for chapter number 1, you're just trying to find the beta of your portfolio, and you're given the expected return of your portfolio at 18%, a risk-free at 6%, and a market return at 14%. So the portfolio for the beta is the difference in return divided by the difference in market return. So after you do 18 minus 6 divided by 14 minus 6, you get 12 divided by 8, which gives you a beta of 1.5.
So who's got 622? Evan, are you gonna put one up? Mike, did you put one up?
Yeah.
Okay, cool. Connor, did you put yours up yet?
Yeah, I'm working on, I found a problem with it because it was from the 10th edition.
It doesn't matter.
Doesn't matter.
I mean, just, I need a couple of problems.
Yeah.
So Brandon, you got your problems? Okay, yeah.
With this one,
Sell short-term shares to current market price of $50 a share. Do that first, you define the value of your shares. You have 100, you multiply that times $50 per share you have, you find 5,000. You do, they give you the
I'd rather have you do calculation
initial margin
instead of,
requirement, which
theory.
is 50%,
Yeah.
1.5. You multiply that times your value of shares, and you get 25.
sorry, could you do that again? I apologize. And then Brandon, can you move a little bit? I need to get,
Alright,
that's
I'm doing chapter 3, number 10A. You are a Bears Telecom and decide to sell short 100 shares at the current market price of $50 per share. So first you define your value of shares, and they basically give you all the information. You take your 100 shares times your $50 a share, and you get 5,000. And next, they give you the initial margin requirement, which is 50% or 0.5. So to find your equity, you have to multiply 5,000 times 0.5, and that ends up as 2,500 in the check.
Thank you. And you can just erase it. And then Mr. Trevino, you did 6.21, right?
Yes.
Yeah, could you erase that for me? So we can make some room for some of these other guys? And then, Ben, you did CFA problem 4, that's already done. Yeah, but you're already done with that one.
Yeah, I'll erase that one.
Yeah. And then who had chapter 6, number 15? Was that you, Kent?
So this is chapter 6, problem set 15. You're managing a risky portfolio and you're trying to find out the reward to volatility ratio, which is also the Sharpe ratio. So the Sharpe ratio is the expected rate of return minus the T-bill rate over the standard deviation. So it'd be 18% minus 8% divided by 28%, which is 0.3571 or 35.
And then what is the Sharpe ratio also? What can it also be used for? What else does it measure? You got it. Slope of the capital allocation line. Nice job. Frick. Guy's just on fire. Okay, yes, sir. Is that 8-9 or 6? 8-9? Okay, hold on.
You want Mike to stick his hand in the garbage, pick up a piece of trash?
Put it in the recycling.
There's a lot of trash.
A tree is crying right now.
I think I can shoot it from here.
What's RC?
Okay, so for this problem, they give you the estimated index model from equity returns from stocks A and B, and they ask for the standard deviation.
Yeah.
So it was pretty simple. They give you the data, plug in the formula. Obviously, from the formula it's squared, so this is the only tricky part. The standard deviation is not 980 and not 4,800. It's squared. So it's 31.30% and 69.28%.
Okay, you just need to speak up a little bit more.
This one ties into that Sharpe ratio one. I'm not really sure how, because I'm using the CML, so maybe Susie could help me out. But Johnson requests that their portfolio standard deviation is to be half of the market standard deviation, which was given at 20%. So our standard deviation for the portfolio would be 10%. The intercept of the capital market line is the risk-free rate, which was given. That was 0.05, and the slope of that is the Sharpe ratio, which is almost similar to that one. Ours is a little lower, it's 0.35. So we're going to multiply the risk-free rate by the Sharpe ratio times the standard deviation of our portfolio, which is half the standard deviation of the market, which is 20%. Gives us our expected return of the portfolio of 8.5%, given these restrictions.
Okay, that's fine. Don't forget to erase it when you're done. Because we got a couple other guys. Anybody need to check the numbers?
I haven't started.
Anybody want to throw some more? You got a couple.
Those on there, but I just want to look at them. I did, one, I can't make it. We're chapter 3. No, not the last margin, the short sale.
Yeah, I was
The second one, that's
waiting
to clear out.
Did we? Well, you showed me, but I didn't want to stop. What chapter is that?
3.
Yeah, you want?
Section short sale.
I don't think I did this one.
We did the Excel sheet together, because you showed me what to change.
Yeah.
So I changed it off that.
Okay. You guys don't have it.
what's going on with LIBOR?
It's a good question. It's going away 2020, I think.
I don't get it, like, it's some, when I'm trying to watch it on TV, it goes over my head and I don't know why they're getting rid of it.
It was basically a rigged system between a bunch of the banks. It was basically a survey of rates by a bunch of traders. So what they would do is it was basically a survey, what are you guys bidding at on the risk-free rate? What they ended up doing was, instead of a survey-based approach for LIBOR, what they were doing was they were colluding.
Were they giving lower rates, lower LIBOR?
Well, whatever positions that they could take to basically arbitrage the derivative trades. So they were actually manipulating the LIBOR to basically manipulate the trades that these guys had on their blocks.
Oh, so the LIBOR wasn't real, I thought it was a bank.
It is, it's like it's like a federal funds rate. So I was thinking the solution probably, instead of a collusion, between traders, to basically do a survey of bid rates on the short end of the curve, that you do like a global weighted average federal funds rate. Where you do it, you basically actually take short-term overnight deposit rates, or 3-month rates on sovereign bond securities on a trade-weighted basis, on a global basis, and use that as a proxy for instead of the manipulation that has occurred. There's like 30 trillion or 300-something trillion dollars of derivatives that are based off of LIBOR.
Yeah.
So when LIBOR goes away, there's going to be contracts in place. They're going to have to replace the underlying rate on these contracts, which is going to be a total disaster. Because when you do that, you got to go back and renegotiate the rate.
Interest rate swaps are, use LIBOR a lot of the time.
Yeah, that's the problem. They're priced off LIBOR instead of a market-determined rate. LIBOR was a consensus, a survey of the bank trader.
I always thought it was the actual number.
No, it's not a market-driven, supply-demand driven rate. It's actually a bid rate.
Wow.
Yeah, so these guys were basically
They could
colluding.
They could stimulate or like cool off the market.
They could create arbitrage profits by colluding and then basically passing on the information to their book makers, which is what happened.
Didn't they already get fined for that,
Smart guys.
5 years ago?
Yeah, but nobody knows what to do. They gotta replace LIBOR.
Is the one.
You got $300 trillion worth of notional value of revenues that are current now, so.
Yeah, I'm just trying to figure out this number. Sometimes they give you false information, but not to take
While Desmond is writing the problem up, I'm gonna go over the spreadsheet real quick. You can keep writing up. So on the spreadsheet, and I just posted the new one, which is version 1.3. So over here, you got your master target portfolio. And maybe you can walk through what we walked through earlier. That's all you gotta do is put in the name, the industry, ticker, stock price, and then your scaling factor. And we had a discussion earlier where you were using Walmart here, and you were using revenue.
Yeah.
And the revenues were off the charts, like 50% of the portfolio was allocated to Walmart. So that's all you gotta do is put in. That's all you gotta do is put in the revenues, and then take down the revenue for Walmart until you get to the maximum allocation.
0.5%.
Yeah, so you say, no stock within the portfolio is gonna get more than 50% of the allocation. So what you do is you just take Walmart.
Oh, did you ask that?
15,
Yeah.
And then
So we
recalibrate
have to do the Excels and then, okay, so those
So I would just hard code the numbers, and then in the comment section, I would say adjusted the revenues down.
So, can you do, are the weights tied to the revenue, or
Yeah.
can you change the weight and then it'll give you the revenue, or
I
do you
didn't
change
do,
the
I didn't
revenue?
do that, the way that I did it was, the revenues calculated these weights, which were tied to these weights.
Yeah.
But if you want to hard code the weights, that's fine, just make sure it adds up to 100. But what I did was I just tied those together. But I said, go ahead and take down the revenues to get to the 15% so that it calibrates across. But if you wanted to go ahead and hard code these after you did these, I would say go ahead and do it. You can do that. Okay? Because it's this column, Dakota, that's generating the, calculating the values, or the dollar exposures, divided by the stock price that gives us the number of shares, and then that sets everything. And then if you go, I did a 1 year, a 3 year, and a 5 year. So that's all you gotta do is go to the 1 year and just put in the stock prices. And it's gonna calculate the 1 year. I already calculated the 1 year for the S&P 500, which was 15.4%. Whatever yours is, your alpha's gonna either be positive or negative. Then what I did was I went back 3 years, same thing. That's all you gotta do is put in the prices.
These are the current prices, not the.
This would be in the master target portfolio would be the current price. This one, the back test 1 year would be prices from a year ago.
Okay.
And then
So you have to have stocks then that can be back tested that far.
you should. If not, just plug it. Just plug it under, because it's not gonna have a material,
Yeah.
Impact on the portfolio. And then I went back, and then put the stock prices in from 5 years ago. So what I'll do is what all of you should do is go back and back test so we can see whose portfolio has performed the best over 1, 3, 5 years ago. And then we're gonna track it. What I would do is in the target portfolio, put the prices for your stocks as of the beginning of the semester. And then in this one right here, the next one, put in the current price and see how you've done so far. So if you built the portfolio and invested it at the beginning of the semester, what's your rate of return currently? How good have you done? And then that one, that first sheet, which is the front test, I call it the front test, that should be as of next Wednesday. You put it in, see how you did. And then by the midterm, you update it, you see how you did then. And then at the end of the semester, you put the prices in, you see how you did. And then we'll benchmark it against the S&P and see if you created alpha. Okay. So that's the first iteration, and then I'll build the Excel spreadsheet to do the rebalancing. Okay. I'll add that in. I've added that layer, and I wanted to do the back testing first. And then we'll do by the end of the semester, we'll do the dynamics. So we'll run it a bunch of ways. Okay. And then we'll put it into a report so you can take it with you.
So when we run the back test.
That's all you gotta do is put in the new price.
But we're gonna have to.
No, the weights stay the same.
Okay.
For the first run, I just said, let's just back test it. Based on the current revenue allocation.
Yeah, that would be fair.
And then we just back test and see how it goes. Because it's not gonna make a material difference.
Yeah.
So through the semester, I'll update this thing and it'll become a little bit more and more dynamic. And then that's all you gotta do is
we just put in the previous stock
put the
prices.
prices in the new spreadsheet.
Let me see
And then
where.
it should become dynamic. You should have a pretty good spreadsheet. Okay, is everybody clear on this? You know what we're doing next week? We're doing the portfolio stuff. We're writing a report. You're basically competing against each other as though you would compete in any shop. You're putting together your proposal for the investment committee that's going to be made next Friday based on your portfolio. The people who did the best in their portfolio, those are the portfolios that will build mutual funds and ETFs off and sell now. So it'll be like Schwab or JP Morgan. Oh, awesome. Oh, you should be a supervisor. If you can't go back, just approximate the number, just use the, if you can only go, and then just go back, just use that number, because it's not gonna be that number. And we can work on it. Oh, yeah, did you use debt and equity or just equity for the total market? This is the value of the equity or the value of the debt in the account?
I'm not sure, we just went to the, it was on the Yahoo Finance and total
Just-
market cap.
Okay, just verify if it's the value of the equity or value of debt in the account. All right, so who's got 8.9? Or did we already do that?
Which one is that?
Okay, can you erase that for me? And then Desmond, you got chapter 212?
I'll do mine after 11.
Okay. Okay, so who has, yeah, okay, let's do it.
Bradley, at the top.
Okay.
This one,
It's okay if you did it over again, just represent it. Or the,
I'm just saying, I don't know if they're all.
okay, go ahead. So Brendan, Evan, you guys are ready?
Yeah, I just wanted to check.
Perfect, thank you. And then you got the solutions, right? It's over here if you need to check your numbers. Okay, you're on.
So we're first finding, the proportion, and then we're gonna find the allocation, and then we're finding the, standard deviation of the rate of return. These numbers are given, the 8% up top is the T-bill rate, 18 is the return, the expected return, and this 28% right here is the standard deviation. So you set it all equal, and then you want to solve for y with some algebra. You would subtract over the 16, or no, you would subtract over the 8 and the 10 on that side, divide, which would give you 0.8, and then with the allocation, you have the 0.8, and you multiply it by each individual stock, which is 25, 32, and 43, which gives you 20, 25.6, and 35.4, and then for the standard deviation, you take the 0.8, which was the expected return, or the T-bill rate, multiplied by the standard deviation, you get 22.4 for the standard
Ravina,
deviation of the
do you have a
rate.
comment?
No, I got confused on A from the math.
Yeah, can you walk us through the algebra a little bit slower?
Yes. So this would be, I think it's 18, I think it was, you have the y, so maybe I didn't do it right.
You just don't meant to have.
Well,
the
it's
plus
gonna be
before the y.
0.1, right? It's gonna be 8%.
Take the plus out before the y.
You got 0.1,
Here?
right?
Nah,
It's
it's
gonna,
on the second line.
Here,
yeah, that's it right there. Yep, that's how it would be.
okay. I got you.
That's right. And then you're gonna bring over the 8. You're gonna take the 8 from the 16, right?
And then divide that by 10.
You got it. And then you're gonna get the y.
Got that number. That makes sense, right? Because the 10% is with the y. so
Yeah,
y
it's
should be-
it's multiplied. It's just getting, obviously, working through the problems, there's a lot of algebra. So you have to be, if you're stuck on some algebra, ask us and we'll walk you through the algebra. We shouldn't skip over the algebra, we should actually work through the algebra, yeah, because it's to practice, so that we get good at it.
I think we all got the algebra pretty good. Sometimes I
Okay.
feel like, it sounds dumb, I feel intimidated because I don't know some of the symbols and like what they mean, like RC, like I've never seen.
Yeah,
return
that's
on
the
that.
return on the complete portfolio.
Okay.
So if you read through the chapters, you'll be able to pick that stuff up. Okay, so I highly recommend, and the chapters don't take that long to read, so I highly recommend reading through. You'll pick up so much more than just doing the problems. When you come in, it'll make a lot more sense. Okay, so force yourself to read the chapters, please. So who's got, Kent, are you 919 or is that you? Okay.
So we're asking to find the beta of the stock, given that the return on the stock is 4%. So we're gonna use the SML, the return on the stock is 4%, our expected return on the interest is,
Brendan, can you check that for me?
risk-free rate is
Can you check that
6%.
answer?
Beta, which we're trying to find, So we're gonna take our expected return on the market minus our risk-free rate, times beta times the risk-free rate equals.
No, it's plus the risk-free rate.
Yeah, plus the risk-free rate gives our return. So we're trying to find the beta. So I subtracted the risk-free rate to the expected return, got me negative 0.02. And then I subtracted the risk-free rate, or the expected return on the market minus the risk-free rate, give me 10%. Divide the 10% to get the beta by itself on one side. Got negative 2% over 10%, which gives a beta of negative 0.2.
Is that correct?
Yeah.
Okay. It's just very rare would you see a negative beta.
I was I checked it. It was
Did
right.
you? Okay.
Yeah, and I thought that was weird too.
Okay. And then who's got 9-1? Okay, Connor, awesome, you're up.
Yeah, so it's pretty simple, just calculating the beta, and it's, so these were the givens. Expected return on the portfolio 18%, risk-free rate is 6%, and the return on the market is 14%. And then here's the calculation, here's the formula for the beta. So plug those in, you're left with 18 minus 6 over 14 minus 6, which gives you 12 over 8, and that's 1.
And then would you do me a favor and just write it, do a line through the risk-free rate? Just right there in the equation, just do a line, just top to bottom, just top to bottom, just go like this, yep, and then do the same thing with the sixes. I just want to show you, just it cancels out from an algebraic standpoint, okay? So you can do the math, or you can just cancel them out, okay? All right, test question. Test question, on the security, or on the portfolio, does it move more or less than the market? Does it move more or less than the market? By how much? Or
50 basis points.
Or 50%,
Yeah.
right? Okay. And then who's got chapter 2? All right, Ivan, let's go. Nice job.
Problem is to find the rate of return of the 3 stocks that have a price-weighted index. And to find T equals 0, the index is 9 plus 50 plus 100 divided by 3, which is 80. At T equals 1, or year 1, the violet index is 95 plus 45 plus 100 divided by 3, which is 83.333. I divided 83.333 by the initial value of the index, which is 80. I subtracted it by 1, and the rate of return is 4.72%.
So let's do the test question on this one. If you get a stock split,
That's what mine is.
oh, you did the one with the stock split, and did you? Is that the one that adjusts the divisor?
Yep.
Okay, cool. Why don't you do that? So if you get a jump in the index, what do you do to the divisor?
Yeah, make the divisor greater.
Yeah, what are you gonna do? You're gonna do what?
Increase the divisor.
You're gonna increase the divisor and it's gonna pull it down, right? And then you align it. So with stock splits, they could cause the index to go up. You increase the divisor to bring it back, and then it's off to the races. So you gotta be comfortable knowing that when you update the index through stock splits or reverse stock splits, you gotta adjust the divisor so that whatever the jump in the index, either positive or negative, it's gotta align, bring back the index back to where it was before by adjusting the divisor.
Is there just proportional shifts?
You have to adjust it, the divisor itself, to bring it back in line so that it starts at the same place.
So however much it jumps, you just proportionally shift the divisor?
You just change the divisor until it goes right back to where it was, and then that's it.
And you could visibly see it move.
Yeah, when you redo the calculation, it's gonna jump up or down, okay, in the index. Then you adjust the divisor to bring it back in line with where it was, and then that's it.
And it's inverse, right? So if you bring it up, it's gonna go down, and if you bring it down.
That's right. Yeah, because it's just a divisor.
Oh.
It's multiplication.
Fraction.
But the key to the whole theory is that you understand that when you do the adjustments, it's gonna mess up the numerator. So then you just You just adjust the divisor to bring it back in line with where it was before, and that's it. And then it's just off to the races after that. That's a huge thing, is divisor adjustments. Okay.
And is that also if a new stock enters like the S&P 500?
Yeah. Yeah, if you swap out one company for another company, it's going to mess up the index, and then you adjust the divisor to bring it back in line. Okay.
Alright, so at the end of period one, stocks they were selling for 110, and at the start of period two, they split that to 55. So I basically just did 95 plus 45 plus 55, and we didn't have the denominator, so I made it equal to what it was equal to at the end of what the index was at T1, which was 83.33, and then I just did the algebra and found the denominator came out to be 2.34, and then I guess what you were just saying about C, which is calculate the rate of return on the second period, which I didn't understand initially. It would just be 0 because the denominator would cancel out.
It adjusts it.
It adjusts it so there would be no return.
Going forward, can we just, for Friday, can we just focus on problems from 9, 8, and 7? 9, 8, 7? Because we don't need to do 2 and 1 and stuff. Let's focus on the portfolio stuff. Okay. All right. Yasmin, would you have 212? Another index one? Did we already do that? Yeah, just go through it.
You wouldn't really have to say like 0 rate of return unless there's a stock.
It's I don't know what the period was, but maybe the index didn't move.
Yeah.
There was no adjustment, but you have to make sure that you adjusted the divisor.
Yeah, so after I adjusted the divisor,
Then that's it.
Yeah.
Then the index will start to go based on the new weightings.
Yeah, gotcha.
So for A, you're just trying to calculate the market value rated index.
Okay, hold on, you guys. Go ahead, and then step to the side. And then walk us through. Okay, Dakota.
To calculate the market value weighted index for the first year. So we just multiply the price and the quantity for each of the 3 stocks, or the 3 stocks, A, B, and C. So that's the 9,000, 10,000, and 20,000. Below that 39. Same thing for the after the end of the first year. And then you divide the end of the first year by the start, and subtract 1 to get the percentage on the return. That was 3.85%. And then after that, they want, what is it called, an equally weighted index, which was pretty much just dividing the ends by the originals for the first year at each individual stock, which was a 9,500 over 9,000, 9,000 over 10,000, and yeah, and then 22 over 20. I think that should have been 10 over, 10 over 10. So for this one you get 5.5%, and then this one I think was a loss of 10%, and then this was a 10% return.
And if you were to calculate the returns, what would you use? Would you use it arithmetic or geometric? Which one's more accurate, arithmetic or geometric? If you're calculating performance returns on the portfolio, geometric. Yeah. Okay. Who had the? Which one is that? I can't read that from her. It looks like the covariance. Okay.
So the covariance is going to take the beta at A and B times the standard deviation of the market. So that's 0.7 times 1.2 times 400, and you get 336. And then for the correlation coefficient, you just take the 336 and divide it by the standard deviations of A and B, and it's 15.5.
So if the correlation and the covariance go up, what happens to the portfolio standard deviation? What? If the correlation or the covariance goes up, in the portfolio standard deviation calculation, what happens to the portfolio standard deviation? If the correlation of covariance goes up, what happens, what?
It goes up.
Goes up. And if it goes down?
Goes down.
If the correlation covariance goes down, the standard deviation goes down. Got it. Thanks, Evan. And then did you want to do yours?
Yeah.
And will you walk us through a little bit slower? I mean, and just speak up a little bit louder. But you do a great job when you do the presentations.
Okay, so this is chapter 7, CFA 10. So this question gives us a bunch of statistics for stocks A, B, and C. You get the standard deviation. They also give us a correlation matrix. So the question they're asking is, we have two portfolios, a portfolio with equal amounts of stocks A and B, and a portfolio with equal amounts of stocks B and C. Which portfolio would you recommend given the information that's up here? So you could easily answer this question by just getting the correlations here. So the correlation of A and B is 0.9, and the correlation of B and C is 0.1. And we know that low, no, and negative correlation means a diversified portfolio. So this is the portfolio you would recommend, B and C, because it's 0.1. But to take it a step further and prove why, we're going to get the standard deviation. To get the standard deviation, we first want the covariance, and because we already have the correlation as well as the standard deviation, we just need the correlation formula, which is equal to covariance divided by the standard deviation of your first asset times the standard deviation of your second asset. So for the first portfolio, which is portfolio with this assets A and B, that's a correlation of 0.90. So 0.90 is equal to covariance divided by the standard deviation that was given to us. Okay. So and then all we're going to do is solve for covariance, and the way we're going to do that is multiply both sides by the denominator. So when we do that, we end up with this, which is 0.9 times 0.4 times 0.2 equals the covariance, and that also equals 0.072. So that's our covariance, which then we're going to use for the portfolio variance, because the portfolio variance is also the standard deviation squared. So portfolio variance is equal to the weight of stock A multiplied by the standard deviation of stock B squared, actually, plus the weight of stock B squared times the standard deviation of B squared, plus 2 times the weight of stock A times the weight of stock B times the covariance, which is what we just got. So that, oh, by the way, the weights are 0.5 since they're equal. So here's our weight, 0.5 squared times 0.4 squared, which is our standard deviation. So you multiply that out, you get 0.04 plus 0.5 squared times 0.2 squared, you multiply that out, you get 0.01 plus 0.2 times 0.5 times 0.5 times our covariance of 0.072, which is equal to 0.036. And you add all that up and you get 0.086 portfolio variance. So now to get the standard deviation, you just square root 0.086, and that equals a 29% standard deviation for this portfolio. Okay? So now we'll do the same thing for the second portfolio with the correlation of 1. We'll grab the covariance again using the same method, and our covariance will end up at 0.008, which is less than the other one, obviously. So we run the same equation for the portfolio variance, and then we get 0.5 squared times 0.2 squared plus 0.5 squared plus 0.4 squared plus 2 times 5, 0.5 times 1.5 times 4, a covariance of 0.008. So you get this, and that's 0.01 plus 0.04 plus 0.004, and that equals 0.054. You square root that to get the standard deviation, and that's a standard deviation of 0.23. So it's kind of overkill, but it just proves a lower correlation equals a lower standard deviation. So we end up with the same conclusion, that the recommended portfolio is the portfolio that includes B and C.
And it, I was just going to say, if you you could calculate if both the portfolios were expected returns were 10%, and the risk-free rate, was, let's say, 5%, and you calculated the Sharpe ratio, what portfolio would you pick?
Go with the steeper count?
Well, in this one, you would. It's basically the numerator is the same, right? It's fixed. So the only thing that really matters is the standard deviation. So you return to risk ratio, you pick the one with the lowest standard deviation because the expected return is the same. Okay. So it looks like, Brendan, you'll be doing yours on Friday. Take some pictures of the solutions for some problems. Pick from 9, 8, and 7, and then bring in the problems for Friday. Okay.
Would it be helpful to know like the date of the IPO for tech companies just to see how
You can put it in the
volatile
comment
it is?
section.
Just so, yeah, because if it was like 2016, it's gonna be super volatile.
Yeah, put that in the comment section.
Yeah, okay.
Yeah.
All right.